Hello and welcome to this very brief presentation related to what I term conflation of properties and operators. I'll define these terms in a moment, but essentially they relate to mathematical terminology associated with arithmetic operations. For example, in the calculation shown below, we could describe this as, considering initially the curly bracket on the top line here, -6 multiplied by 3 minus, in brackets, -10 multiplied by 5, and then the curly bracket is now multiplied by 2 to the power of -2, and that's all divided by 2 multiplied by -4. Evaluating, the answer is -1. However, we could describe the calculation as follows. Again, initially considering the curly bracket on the top line here, we have -6 times by 3, subtract. In the next bracket we have -10 times by 5, and then the curly bracket is times by 2 to the -2, and that's all over 2 times -4. The answer is -1. So it's two sets of terminology I've used to describe the same calculation, both of which are acceptable. But unfortunately, often conflation occurs where we mix and match the two sets of terminology. And it's this conflation of the terminology that we're going to try and highlight in this short presentation. Let's consider the presentation overview. We commence with definitions of the mathematical terms, properties, operators, and we also define the term conflation for the purposes of this presentation. Next, we consider the pros, the benefits of using conflation, essentially the benefits of exposing technician engineers to this particular issue. It's unlikely something they have considered in previous engineering math study. Then we consider the cons, the disadvantages of using conflation. These are mainly concerns from mathematicians, incorrect usage of terminology within calculations or discussions. Next, we briefly consider technician engineers' typical perspectives on studying engineering mathematics. Also, applying mathematics and engineering is seen more of a tool for solving real-world problems within engineering and design analyses. Although maths is quite essential within lots of engineering applications to help us design products, ensure safety, integrity of structures, we often do in engineering also rely on established rules of thumb or established practices, and there are instances where we just don't have literally the time to apply mathematical analyses to the extent we would like to, due to pressures of production, budgets, etc., etc. As I said, it's a brief real-world overview of applying engineering maths. And finally, we consider some illustrations of where conflation of terminology occurs within calculations. And the whole essence of this presentation is purely to provide an awareness of the conflation of mathematical terms both myself and students' tendency to exhibit when we're undertaking mathematical problems or discussing mathematical solutions. For your expediency, you can, if you prefer, ignore the first 5 sections of the presentation and instead just review the last section of the presentation. The first 5 sections are included to form a backdrop to the presentation to set the context of technician engineer's perspective on studying mathematics. The main body and essence of the presentation is contained in this last section that includes the illustrations of conflation of terminology. And for reference, here are the approximate start times related to the various sections within the presentation, hopefully to aid your ease of access through the presentation. But as always, please remember these are only approximate start times. Firstly, some definitions we'll be using. The first one is conflation. My definition of conflation is the combining or the blending of 2 or more separate entities into one entity. Property in this presentation relates to that of a number, such as whether the number is positive or negative. And here's a number line showing the positive direction, from left to right, and the negative direction right to left. In mathematics, the term operation usually refers to the mathematical process being undertaken, for example, add, subtract, multiply and divide. Sometimes the term operator is used, and that's considered to refer to the symbol representing the mathematical process. So add here, subtract, multiply or times, and divide. Sometimes there are two symbols for divide used within calculations. So we're going to use this terminology to underpin our presentation. You'll actually see in the presentation that follows, I'll conflate the terms operation and operator anyway, just to try and simplify the presentation. Now it can be considered that there are actually benefits or pros of conflating the various terms. For example, students become familiar and comfortable with the various terms, or conflating the number property negative with the operation of minus, as these terms will be encountered and conflated within general calculations and indeed within general parlance, general usage. A typical example occurs within a weather forecast. Sometimes the weather forecaster will state that the temperature today was minus 2 degrees Celsius, as opposed to stating negative 2 degrees Celsius. Within an industrial context, an engineer might state that the force applied to the component is minus 10 kilonewtons, as opposed to negative 10 kilonewtons. So again, we're conflating the terms minus and negative here. But this could happen within an engineering context where, for example, engineers are discussing an analysis and referring to the load applied to the component or structure. So the point I'm trying to make here is that although we should use the terms negative and minus correctly within calculations, in practice they will be interchanged. As long as we're aware of the difference, then it's essentially acceptable to do so. In mechanical engineering, often weight and mass are also conflated within general discussions, within specifications. Sometimes the weight is stated in terms of kilograms, but as engineers we need to realise that weight force actually has the SI unit of the Newton. So again, that's conflation, but as long as we're clearly aware of the difference between mass and weight, in essence the conflation doesn't really bother us. However, the disadvantages or cons of the conflation of our terminology relate to the following. The term negative is actually an adjective that describes the property of the number, whereas the term minus is a verb that describes an action or an operation, in this case to take something away. So for example, in this calculation here, we have 25 minus negative 12. The minus relates to the fact we are subtracting the numbers, and a negative is the property of the number 12. So in other words, when we state negative 12, this is considered to be unambiguous. That's the property of the number, it's a negative value. But if we state minus 12, that can be ambiguous because that could mean we have negative 12, or it could mean we have to subtract 12. And also this ambiguity can cause further confusion when we state that two minuses make a plus, as would be the case in this calculation here. So there's some disadvantages that mathematicians particularly would highlight when we conflate the terms negative and minus. Here's an extract from our previous presentation related to BODMAS, where we use the terminology of like signs and unlike signs to note the consequences of various arithmetic operations. This tends to be the usual approach that engineering textbooks take when explaining these arithmetic operations to technician engineering students. Now I do realise that this presentation and the contents therein may not be of particular interest to technician engineering students, as generally speaking mathematics is not one of their favourite topic areas. As one student said to me many years ago, I didn't enrol on the engineering programme because I wanted to study mathematics. And another student said, if I'd wanted to be a mathematician, I'd have studied A-level maths. And in fairness to the students, they typically will study 12 units over a 2-year period, only one of which is specifically mathematics. Although of course other units such as science and electrical and mechanical principles are underpinned by mathematics. So as I do very much appreciate these student sentiments, I still think it's useful to have awareness of the terminology that's used within mathematics, even though I'm sure they, and indeed I myself, will tend to conflate these various mathematical terms. Indeed, on reflecting of 20 years' experience of working in various design and stress offices, the conflation that I'm highlighting here of the terminology is something I can never recall being an issue in all the stress analysis reports I've produced, presentations undertaken, seminars attended, or in general conversation with other engineers. So essentially, from a technician engineering perspective, maths is seen as more so a useful tool as opposed to, say, a mathematician, where it is the central focus of their particular work. Within engineering, often time constraints can limit mathematical analyses. Maybe there's a problem on the shop floor that has to be resolved, so there's not time to engage with any meaningful mathematical analysis, and perhaps engineering judgments or past experience has to be used to solve a problem. Sometimes the assumptions or the idealizations that are made can cause the mathematical models or analyses to be rather simplistic. In engineering, we often use factors of safety applied to engineering components that endeavours to account for the various analysis inaccuracies or unknowns. And indeed, within engineering, rules of thumb are often used in seeking a solution to a problem. Sometimes this approach is termed the use of heuristics. So what I'm trying to say from a technician engineering perspective is that maths is part of the picture, part of the process within engineering design context. But we tend to see it more so as a useful tool to aid us with our design and analysis of components. But it's not seen in the same light as, for example, perhaps a mathematician would engage with mathematics. So we tend to be a bit more loose with our use of mathematical terminology. That said, I do think it's beneficial to highlight to students the conflation that can occur, and the rest of the presentation now endeavours to do so. And I have to say, I very often do conflate my mathematical terms, as you will see in some of the lectures on this YouTube channel. Here's a brief recap of properties and operators, a topic area we reviewed in our previous presentation related to BODMAS. The property of a number or an algebraic symbol is usually stated as positive or negative. Within calculations, we have operators, such as typically a plus and a minus. So if we consider the illustration shown on the right hand side here, within the upper calculation, this would be stated as negative 3 minus 2 multiplied by 5 plus 2 raised to the power of negative 2. With the lower calculation, we have a positive y raised to the power of negative 3. We're multiplying that by negative 5y squared minus negative 3 multiplied by y to the power of negative 1. However, sometimes the property of a number or algebraic symbol may be stated as plus or minus, in which case our operators now become add and subtract, or sometimes take away. If we now again consider our illustrations, for the upper calculation, we would now have minus 3 subtract 2 multiplied by 5, or sometimes termed 2 times 5, add 2 to the power of minus 2. Considering the lower calculation, we would have plus y to the minus 3 times by minus 5y squared, subtract minus 3y raised to the power of minus 1. So sometimes this different terminology can be used within calculations. What I just wanted to highlight to you here is that sometimes properties and operators can be conflated. So these are examples of conflation. So here I'm returning to the calculations and showing you how the terminology is conflated. If you notice in the upper line now, this states a minus 3 minus 2 times 5 add 2 to the power of negative 2. Can you see that the properties and the operators are conflated here? We've used minus initially to mean the property of the 3, but we're also using the term minus for the operation within the calculation. And considering the lower calculation, we have positive y raised to the minus 3. We're timesing that by minus 5. Then we're subtracting minus 3 raised to the negative 1. And again, we have conflation here because the property of the first term is defined as positive, but the properties of the second and third terms are defined as minus instead of negative. So the point I'm trying to make here is that conflation can occur within calculations, and unfortunately I do often conflate my properties and my operators. So I'm going to apologize for that. Obviously we should be very consistent within our terminology used in the calculations. So we really should be using properties denoted as positive and negative, and operators, for example, the plus and the minus. I'm very briefly referring to the quadratic formula that's used. It should state x is equal to negative b plus or minus the square root of b squared minus 4ac, or divided by 2a. Alternatively, the quadratic formula could be stated as x is equal to minus b add or subtract the square root of b squared subtract 4ac, or divided by 2a. Here again is an example of conflation by stating x is equal to minus b plus or minus the square root of b squared minus 4ac, or divided by 2a. We have conflation here because the first minus relates to the property, but the minus used here and here relates to operations. But I'm just trying to make you aware of my misuse of the terminology. Again, I would encourage you to try and be consistent with your terminology for properties and for operators. So I hope this presentation has highlighted to you the potential conflation that can occur within the way we describe mathematical calculations, and to give you an awareness of such considerations. Thank you for viewing.